This is lesson 4.4, parallel and perpendicular lines. Parallel lines are lines that never intersect. They never cross each other. In this case, their slopes are identical because they rise and fall at the same rate. So some examples in the real world would be like if you had a box, the sides of the box or the sides of your phone or laptop, those are parallel lines. Railroad tracks on either end, those are parallel lines. They're never going to intersect. Your desk legs, there's tons of examples in the real world where two lines never cross each other. Perpendicular lines are lines that intersect at a 90-degree angle. Their slopes are what are called negative reciprocals of each other. I'll explain what that is in a second. Examples of perpendicular lines in the real world might be across the corner of a box, an intersection on the road, the corner of a room, lots of examples. A negative reciprocal is when you flip the fraction and change the sign. So reciprocal means you're flipping something, and then of course negative reciprocal means you're multiplying it by -1. You're changing what the sign is. So the negative reciprocal of 2 is -1/2 because you flip the fraction and change the sign from positive to negative. In this example, the negative reciprocal of -2/3 is just +3/2. Flip the fraction, change the sign. In these two graphs, I have examples of parallel lines and perpendicular lines. So these are parallel lines that are going to continue forever and never intersect, never cross each other. This is the notation to say that these two lines are parallel, whatever the notation, whatever letter you've assigned to the line, and then two straight lines that indicates parallel, and then the other line there. So A is parallel to B. That's what that means there. And then these are perpendicular lines, so they're crossing at 90-degree angles. And this is the notation used. So the same thing, but instead of two straight lines, you have one line intersecting another at 90-degree angles. That means these two lines are perpendicular. And we can check that they definitely are parallel and perpendicular by comparing their slopes. So for this one, slope A and slope B, I just counted the rise and run for both and found that they have identical slopes of 2. For the perpendicular example, again, I counted the rise and run of both. Slope A is 2/3, slope B is -3/2, so the negative reciprocal. Example 1 here, we want to determine if the slopes are parallel, perpendicular, or neither, and explain our choice. So our first example, this is neither. Although the fraction flips 1/2 to 2, the sign doesn't change, so it's not parallel, it's not perpendicular. In example B, these are identical slopes, so they're parallel lines. Example C, we went from -2/7. We flipped the fraction and changed the sign. So these are negative reciprocals of each other, which means that these two slopes are of lines that are perpendicular to each other. And example D, these are also perpendicular to each other because the two slopes are negative reciprocals of each other. We flipped 1/4 and then changed the sign because 1/4 flipped is 4/1, which we just write as 4. In this next example, given the following pairs of points, determine if the lines A and B are parallel, perpendicular, or neither. So there's example A. We have the 2 points given. We don't have a graph, and we have to calculate the slopes to see if they're equal, negative reciprocals, or neither. When we use our y2 minus y1 over x2 minus x1 formula, we find that the slope for line A and B is both 4/7. So these lines are parallel, and we explain that it's because they have identical slopes. So make sure you not only have the correct answer, but you also explain how you know. Another note here to make sure you always fully reduce your fraction. For slope B, we actually got 8/14. If you didn't reduce that fraction, you might say, well, these slopes are not equal, so they're not parallel. But once you reduce the fraction by dividing the top and bottom by 2, you find that they are, in fact, the same slope. Here's example B, same idea. So we calculate the slope of line A and line B by using our slope formula. And we find that they're not quite, they're going to be neither because we have -1/3 and then +1/3. So they're not quite identical lines, but they're also not negative reciprocals because you didn't flip the fraction. So these are neither. Like maybe it looks like this and like this, and that's okay. The last example here is a kind of the trickier type of question you could see with parallel and perpendicular lines. You want to show that these points are the vertices of a square. So a reminder that a vertice, or the vertex, these are corners. So do these 4 points represent corners of a square? So the first step, you're given this grid, the first step would be to plot all of these points and connect them. And once you do that, you look at it and say, well, yeah, that looks like a square. But you can't just say, this looks like a square, my question's done, I'm good to go. Because although it looks like it's a square, you don't necessarily know if the lines are exactly parallel and perpendicular. What we know about squares is that the opposite sides have to be parallel to each other, and the adjacent sides, or all of the corners, have to be 90 degrees. So essentially, we need to check all 4 of these slopes for these 4 line segments and check that the appropriate lines are parallel or perpendicular to each other. Because it's possible it looks like a square, but then once we do the calculation, it's not quite a square. So I calculated the 4 slopes, AB, BC, CD, and DA. That's what I've done here, calculated all 4 slopes. And then I confirmed that it is a square because, and I'm using my notation here that we learned above, line AB is parallel to line CD because I found that the slopes here are 1/4 and 1/4. So those two are parallel to each other because they have equal slopes. And then I also found that line BC is parallel to line DA because they both have slope of -4. So that's good. We've checked off that the correct lines are parallel to each other. We also had to check that all the corners are 90 degrees. So we found that line AB is perpendicular to line BC because the slopes are 1/4 and -4. And those are negative reciprocals of each other because you flip the fraction and change the sign. So that corner is good. We also checked the other corner with AB. AB and DA we found are also perpendicular because it was 1/4 and -4. So those 2 corners are good. We also checked that the other corners are perpendicular, so CD and BC. These are perpendicular with each other because they're negative reciprocals, and then CD with DA. So essentially, you just checked all 4 corners and found that those line segments are perpendicular, so it has to be meeting at a 90-degree angle, and all the opposite lines are parallel to each other. So this is kind of the most complex version of a question you could see with parallel and perpendicular lines, but the main thing to take away is that parallel lines have equal slopes, and perpendicular lines have slopes that are negative reciprocals of each other. And you should be able to identify what they look like on a graph and where you might see them in the real world.